For centuries, human value acted as a filter for the natural world. Gold was seen primarily as a symbol of divine royalty and wealth, a status object long before it was treated as a subject of study. Iron was viewed through an entirely different lens. It was considered cheap dirt, or a functional tool, with no perceived relationship to the precious metals of the ruling class. 1,200 years ago, there was no clear scientific system to explain why materials behaved the way they did. Materials were categorized by superficial traits, like their color or their price tag, leaving a vacuum where a logical framework should have been. Chemistry remained a collection of disconnected observations. Without a way to group materials by their actual properties, researchers were forced to rely on speculation rather than a unified science. This began to change with Jabir ibn Hayyan. He realized that to understand the world, he had to ignore what a material was worth and observe how it behaved under pressure in the laboratory. His methodology marked the transition from judging materials by human perception to analyzing them by their objective properties. Jabir brought gold, silver, copper, iron, lead, and tin into a controlled setting, stripping away their cultural context to treat them as raw data. He tested for hardness, systematically scratching different materials against one another to identify which ones resisted damage and which ones were softer. He moved toward quantitative measurement by investigating weight. By measuring mass, he recognized that distinct densities were a defining characteristic of these materials. He then introduced heat, discovering that each material required a specific, consistent amount of energy before changing from a solid into a liquid. Finally, he tested reactivity. When exposed to various chemical agents, these substances behaved with consistency. The results were clear. While gold and iron looked nothing alike, they shared fundamental characteristics. They were solid under normal conditions, could be reshaped, and displayed consistent chemical behavior. This evidence allowed Jabir to establish metals as a distinct scientific category based on observable physical and chemical behavior. By replacing random speculation with this predictable framework, he provided the logical foundation for the future of chemistry. Once metals were recognized as a single category, scientists could finally compare them, allowing for the systematic refining and improvement of materials. This systematic study of gold, silver, and iron laid the groundwork for metallurgy, the science of refining and working with metals that powers modern industry. We now use concepts like atomic structure and metallic bonding to explain these traits, but the properties we are explaining are the same ones Jabir first identified in his lab. This chart, the periodic table, is the modern evolution of Jabir's logic. It remains the most important tool for organizing the elements. The metals here are still grouped together because they share the same behaviors first documented 1,200 years ago. Jabir's legacy is the principle that careful measurement and logical classification, rather than outward appearance, reveal the true nature of the materials that make up our world.